You probably thought I would never finish this, but here it is, the next part of my simple electronic constant current load. Yeah, meanwhile I got all the missing parts, mainly 1% resistors where I used, on the breadboard 5% types. And I was able to do some layout, and I have some photosensitive PCB material here. And yeah, since you have seen me etching PCBs and UV exposing them and soldering often enough, we will speed things up just a bit. Now I have the right size of photosensitive PCB material, and it's always astounding how easily that diamond-coated blade slices through that glass fiber PCB material. I love it. Now I have a pretty decent exposure mask for the board. I made a mistake when I printed that out and I just realized it, but we talk about that later. Now I have a hopefully properly exposed PCB board. Yeah, I lately made a change to that UV exposure unit, changing the current regulation for the LEDs from a simple series resistor to a real plus minus 2% or so constant current one. Card link. Anyway, let's go to the wet work. Now I have a rather splendidly exposed board. Now I have an etch board, and just for the record, this time it took about 40 minutes, and it's the fourth time I'm using that solution. So yeah, still going strong, that stuff. Now I have removed the rest of the photosensitive stuff, and that concludes the wet work. Time to talk about the mistake I made. When I printed the exposure mask, I did not only include the traces, but also, here you can see it, the board outline, which would cause some shorts, obviously. However, these hairlines obviously didn't survive the exposure and etching process. So yeah, I'm fine. Yeah, the board needed 2 cutouts here at the end so it would fit into the case, which it's got now. Perfect. Time for drilling. Now I got a drilled PCB, and just for the record, for the first time I used diamond-coated drill bits and they worked perfectly. I mean, it's like drilling into butter, and there were a lot of holes, and the first drill I used for all the holes, 0.8 millimeters, it's still going strong. Yeah, no sign of tear and wear. And yeah, these were from, can I have a focus please? From the company Rona. Okay, I don't know, they were not quite cheap, 10 or 20 bucks, more like 20 bucks, but yeah, they're worth it, definitely. The board is cleaned on both sides, of course, and on the copper side, I sprayed it with some solderable varnish. I'm using, as always, SK10 from Contact. Finally, I have a fully populated board. Just a few details, okay. My shunt resistor has a, it's standing off the board, so it has a nice airflow around it. And the real current carrying traces, they are all tint. That's it. Now let's slow down again and assemble the whole thing, huh? So, assembly. Let's first screw the board into the bottom half of the case, and yeah, we should do it the right way around. And oh yeah, looks like the holes are fitting. Yeah, that would have been a bummer. And yes, I meanwhile labeled all the screw terminals because this should make life a wee bit easier. So let's see, what's important here is I have enough clearing around these two thingies where, yeah, the screws of the case itself come in. But yeah, looks good that way. Perfect fit, huh? Yeah, actually, yeah, from the drawings of the case, which I used to dimension the PCB, there would have been a little bit more space here. Or maybe something else in the case is interfering there, but oh yeah, I see it. But no, actually, yeah. There are some mounting brackets in the upper case if you want to put in boards vertically. And yeah, they obviously interfere a little bit here, but yeah, you could make your board a little bit bigger. Anyway, let's cable the thing up. So, gone is the breadboard, and I've, yeah, use some heat shrink stuff to bundle up all the different cable pairs that will go to the board. So yeah, because yeah, I'm expecting it will be a little bit tricky to close that up. Anyway, the goal is still, with all these cables hanging out here, to have that thing up and running, up and running like this. So you see some of the cables I can shorten a little bit, others I can't. And I really have to watch out which I cut and which I don't. So forgive me if I don't do that on camera. I show you the result when I'm finished. So all the cable bundles now have, yeah, the appropriate length to exactly reach to the screw terminals. And that kind of work reminded me of a saying our machine shop teacher had in school. You cannot file something on once you filed it off. So yeah, one bad snip here and yeah, you're redoing all the cabling or part of the cabling inside here, which would be a real annoyance. Anyway, I had an idea. So my initial idea why I used these really small screw terminals is of course space. Not as much in depth, but in height. Yeah, it's quite full in here. And yeah, the plan was to screw in each cable individually. But yeah, that's kind of annoying. And so I thought I use these 90-degree posts. And because they fit in here into this screw terminal quite perfectly, can I get a zoom down here? They fit in quite perfectly and don't take up much space. Yeah, the cables can go on here. Only problem is I have to search for more of them because that's the only one I found so far. So everything's nice and tidy in here now. Yeah, I did run out of the 90-degree post type, and yeah, I had to bend some normal straight posts into form. I hope that works out and nothing breaks, and we can put everything together now without, yeah, fumbling too much with the cables. Yeah. Let's start in the right order. Wonderful. I was fumbling a little bit with the last one. And now we can connect our battery, hopefully. And switch it on. And okay, that looks good. Even, I don't know if you can see that, but if I switch it on, the LED for the battery blinks briefly, and the warning overload LED also blinks briefly. And that's exactly how it should be. Yeah, I'm pretty sure I didn't mix them up, even if both have a pink cable. Okay, lilac cable. Let's break out the power supply and do a final test in the assembled state. And yeah, maybe I messed up something here. Who knows? Okay, the great moment. Might be a great disappointment. Current is turned down. Voltage here on the supply is turned down. Let's, yeah, switch it on and let's go for a few volts. Can you see that? Yeah, it's displaying it. It's 0.75 and 0.745, so we're right on the money. Let's go for something small at first. 2 volts. Yeah, so voltmeter is really right on the money here. That's nice. And turn on the current. And yeah, you can see here on the analog ammeter if something happening. Yeah, and it is. 30 milliamps. Maybe I should change the range to the low range. Yeah, works perfectly. Yeah, I know, you cannot read it. I'm at 104. 200 milliamps. Yeah, is about right with my analog ammeter here, but I will now, yeah, and if I change the range, of course, I go a little bit in overload, sorry. Yeah, let me change the cabling and put the ammeter here in series, so we can see how accurate that thing actually is. So, yeah, the built-in ammeter says 200 milliamps, and the big one here says 201. I won't even bother trying to calibrate that. Plus minus 1 digit is completely okay. Let's see how much we can do here in the lower range. I might need to step up the voltage here. So, and you see it's pretty stable, even if I crank up the voltage to max 25 volts or so. Yeah, I'm doing that to keep the losses, it's just a linear regulator, the losses in here at a limit. And yeah, let's crank up the lower range, which goes to 450 milliamps. Okay, I think I designed it, I had to look it up, for 500 milliamps, but yeah, the shunt resistor is not the most precise. So yeah, well, that's it. Now crank it down again and go to the high range. And yeah, I think I should be able to, oh no, now it's already limiting. Too bad, but yeah, but working. So I can't really put that into limiting mode with that power supply. That's also something. All the LEDs broken. No, it isn't. It's really, this thing has, yeah, not enough power to really get that thing here sweating. Gets them warm. Yeah, have to do something about that one here too. Yeah, low range. Perfectly. If you need, yeah, something in the single digit milliamps, you can do that. Okay, perfect. Let's try to put that thing together now with all the cables and see if, yeah, if my construction was okay in respect to, yeah, the spacing here, the vertical spacing between all the parts and on the board and the parts that stick into the case. Okay, found my case screws that were delivered with the case. Yeah, battery connector should go out here, and now let's see if we can squeeze that all together. Okay, that's actually not that easy. So I have enough space in the back here. So let's get that all to the back. Let's get all that to the front. Almost, but not quite. Yep. And it's closed. And where are my screws? Here. So that was actually some fumbling around. But hey, it's a handheld case. And something happened somewhere here on some computer. Not self-tapping screws, of course, but real threaded screws. Still in one piece. Okay. Battery. Should fit in like that, in theory. Yeah, with the board here, you see the fuse holder. Struggling here a bit. But it should be a tight fit. But not that tight. No, obviously I didn't count on that thingy here. That's a bummer. There's no way to get the battery in with the battery connector on. Jeez, really? The last second. Defeat. Impossible. Give me a sec. Okay, the day has been saved. Can you see that? Yeah, these lips here, I shortened them. I simply nibbled them away up to the board with a side cutter. And now, hopefully, very hopefully, somehow I forgot about that lip, or I bought a battery connector that is too thick, but now the battery should just drop in like it's supposed to drop in. And now for closing up the whole thing. Wow. And yeah, wow, still working. Okay, that was the simple electronic constant current load, and yeah, little mechanical problems at the end, but worked out quite nice. And yeah, this is a handy tool to have in the lab. Yeah, could use some feet. I will probably put some feet on here, and but that's more mechanical work. Some stand that you can put it probably up like the other instruments. But yeah, I'm happy. My layout was okay. Didn't mess up when soldering in the parts. Everything works. Great day. Till next time. Bye.